a startup company to commercialize a technology licensed from University of Michigan. I'm very excited about this product and this technology because we believe it's going to be becoming leading technologies in the flexible, transparent conductors. Okay. I should say that, in fact, many optoelectronic devices, okay, any device that you need to light in and light out, right, essentially need this transparent conductor, right? This can extend to light-emitting diodes, okay, solar cells, and so on and so forth. So right now, this big pie is occupied basically by ITO, right? The technology has been in existence for half a century, okay? Now, all of us want to have a good bite of this big pie, right? Now, our angle, our point of entry, right, to this, rather than just, having low resistance that can cover a large area, our entry angle will be guided by the market direction. Okay, that is, the optoelectronic devices, especially displays, are going toward flexible. Okay, so many major companies shown here, right, actually doing this transition. Okay, there are a lot of talks about flexible, but when are we going to see it? Right? That's a question I have actually asked myself, and many other people ask me as well. Okay, so earlier this year, Samsung has made this release that they're going to have a foldable phone, right, somewhere by the end of this year. Okay, and in September, I was able to participate. Well, this foldable phone basically is a tablet, a foldable tablet in your pocket. Okay, in September, I attended a forum in Shenzhen where a number of companies had this forecast, right, all showing the foldable phone start to ship by the year 2019, and it has a rapid growth in the next few years. Okay, and actually, yesterday, this Chinese company, Royal Rouyu, has announced, starting from today, they're going to ship the first. They claim the first foldable phones. Yeah, so presumably today you can actually buy this from the market. Yeah. So foldable or flexible displays are here now. We don't have to wait. Okay. Now that's the opportunity for all of us, right? Now the question is, of course, ITO, can it meet this demand? Okay. ITO, it is a ceramic material, so it's very brittle, just like iPhone glass, right? Can easily break. If you fold, if you try to bend the ITO too much, it will create these cracks, okay, that lead to a failure, electrical failure. Okay. Now, to solve this problem, there have been many solutions. Right? People have investigated carbon nanotubes, right? Graphenes, silver nanowires, as you just saw, right? And we have actually looked at this problem a long time ago, over 10 years ago. Yeah, we published perhaps the first paper on this, proposing using the metal mesh, metal grid, as a transparent conductor. At that time, in fact, the MIT Tech Review had a news media report on this. Yeah, it's a big and bright, flexible display. In fact, our OLED display, OLED device at that time is very small, but they can see that this can potentially go very big, as we can see now. Right? Yeah. So this, of course, you can bend it, not a problem. Yeah. And in the following years, we developed a number of follow-up technologies, especially continuous row-to-row patterning, right, to be able to pattern, create large area in order to have a low cost. Yeah. So here, the silver nanomesh is different from the silver nanowire. The silver nanowire is I would say, bottom-up, right? Starting from chemical synthesis, and you lay down in a film. Here is more of a semiconductor process. It's top-down, right? It involves patterning. Okay. So, but overall, even though I started a long time ago, but I'm not totally satisfied with this solution, because you can see that it's shown in this diagram. Okay. It's a mesh, okay? Only the mesh, only these wires are conducting, okay? The rest area is non-conducting, okay? Just like if you look at the windows, right? Overall it's transparent, right? But only the frame is actually conducting. So it cannot be a direct replacement for ITO for many products, for many devices, okay? So, so what's our current solution that I'm going to talk is it's completely transparent and completely conducting film across the film. Okay, every point, well, you can hardly see because it's very transparent. Every point on this film is conducting. Okay, that's the big difference between this technology than any other mesh or super nanowire based. Okay, so what's the secret sauce, right? So this actually we also use silver, right? So you may wonder why it's difficult to deposit silver right, into a film. Right? Here, in order to have the silver film to be very transparent, right, the key thing is to make it very thin. Right? So that's why light can go through. But when you deposit this very thin film, right, silver film, onto a substrate, it actually forms this island. Right? Basically, they can get to a point not conducting. And so they scatter a lot of light and cause a lot of electrical loss. Okay? Our technology basically can allow you to create a very thin and smooth silver film. Okay? That make it a very transparent as well. Okay? So therefore, it provides the optical transparency as well as the electric conductivity. Okay? And just by doing this, in fact, it can significantly improve the durability of the silver. Okay? The silver we know is actually quite unstable under many circumstances. Okay? Now, so what's the key advantages that we see in our technology? I will name 3 of them. Okay? First one is high performance. Okay? Now that's the key thing, right? We don't just compete with price, we compete with performance. Right? So you can see from this chart, right? Looking at either from the resistance, transparency, and haze, our technology all actually shows very good performance. Okay, I especially want to point out, right, for handheld device, right, our eye is actually very picky. So the haze, okay, the haze is very important. Right? Whenever you have a grid or wires, they always scatter light. But when you have a continuous film, it won't. Okay, just like ITO. Yeah. So our technology, without doing anything else, it naturally provides the low haze. That's very much needed for handheld device. Okay. And the other thing is from a manufacturing point of view, right? As you can see from previous talks, right? It actually involves a lot of innovation, right? That's why there are so many patents filed, right? In order to actually develop the film. Yeah. So it's either from the mesh or the wires. It's actually quite involved. Ours, on the other hand, is very straightforward. It only involves very industrialized sputtering coating. Okay. So therefore, it provides the flexibility, high conductivity, and simple manufacturing combined into one package, right? So the second advantage, because it's simple to fabricate, it's easily scalable to industrial volume production, right? Now, here I show you a picture that I took just actually in September, where we did the mid-scale. This is a startup. We're actually doing the mid-scale test at the institute, which have this basically industrial scale roll-to-roll sputtering machine. Okay, and over there, that I'm holding 4 sheets, right, just off the right off the oven, cut into 4 sheet transparent conductors. Okay, so this, in fact, the roll, right, we put in 500 meters, right, just in one coating to come out its product. Okay, so it's very scalable. The third one is cost competitive. Okay. So here I actually mentioned previously, right, super nanowires are all solution-based, so potentially low cost, right? I always have a concern because we use vacuum process, right? But having this trip, in fact, I went to Germany, be able to meet with the supplier of the manufacturing tool, right? They actually did a very good job. They did a very fairly detailed cost of ownership analysis. So therefore, we believe that from the performance and cost, they're all superior than some of the competing technologies. So some application demonstrations, a lot of these are actually done in the lab. This is one customer actually in China. They are very interested in our product. They're working on this PDLC-based smart window, right? And the flexible touch panel, that's actually we did in the lab. And this result was provided by a startup company in the US. Okay, they are actually doing electrochromic mirrors, right? They were very happy and they want to use our product as well because as you can see from this comparison, right, with the same level of transparency, our product, right, can have a much higher, much faster switching time than ITO based. Okay, so in fact, it's approaching the intrinsic switching time of the molecules itself. Okay, now looking ahead, right, I think that there are many other things that can be realized with this product. For example, we have made in our laboratory, right, flexible OLED devices. Okay, not only this, of course OLED displays in one area, but I'm personally very interested in developing OLED lighting. Okay, because it can give you a very different form factor, right? You can decorate your home rather than just lighting the home, right? And this is something very recent, actually with collaboration with Professor Forrest group in university, we actually made very high efficiency, transparent organic solar cells. Okay, so basically harvesting the infrared portion of the light. Okay, and we can already get efficiency over 8.5%. Now, this is something we're still in writing, filing patent and so on and so forth. Yeah. So there are many things that can be realized because this is a film that can really replace ITO. Every point can inject charges and extract charges. Right? That's made it possible. So of course, we like many other things we did. Bending test, comparing with some of the other technologies. Yeah, and bending as well as the high temperature, high humidity test. Yeah. So just to compare different technologies and different companies. But here, just on top of this, I want to put our technology as in comparison, right? So it offers very low resistance because it is continuous film rather than these discrete wires. Okay, so naturally very conductive and high transparency and low haze. Okay, that's a key advantage, right? I think that's what I want to talk about on this transparent film technology.